So the next topic is about streamline flow and turbulent flow. So far we discussed about fluid statics. So now we are going to discuss about fluid dynamics, in which the fluid will definitely move. So streamline flow. So streamline flow and turbulent flow. So streamline flow is nothing but the layers of the fluid will not get mixed, will not get turbulent, will not be sticky, okay, and will not the velocity will be remaining constant over there. There will be no variation in the velocity. So those liquids are considered as streamline flow, and turbulent flow is the opposite of streamline flow. So this fluid flow is said to be turbulent because the velocity of the particles will vary at every point, and these fluid particles are moving here and there, and they are not moving in an organized manner. So the mixing will happen between the fluids so that the eddies are generated by this flow. So eddies are same as ripples. So all the particles are moving here and there randomly. So we call this as turbulent flow. So the next topic is about Bernoulli's principle. So Bernoulli's principle works under these things. So here we have to take a streamline flow of liquid. So for a streamline flow of liquid, the sum of pressure, kinetic energy per unit volume, that is rho v square by 2, and potential energy per unit volume, that is rho gh, remains constant. So mathematically we can conclude that P plus rho v square by 2 plus rho gh is equal to constant. Okay, so this is the topic about Bernoulli's principle. So the law states that pressure, kinetic energy per unit volume, potential energy per unit volume remains constant. Okay, so and also speaking about the derivation of this whole equation, so you have to consider a streamline flow of liquid where the no mixing takes place and the velocity of the fluid remains constant. So the fluid flow through the pipe of varying width, we are taking a varying width, and pipe is located at changing heights. Okay, so that to create a pressure difference, so the fluid is incompressible in the sense we have to take liquid again, and the fluid is laminar in the sense uniform, and no energy is lost due to friction, so that it is applicable to non-viscous liquids. So mathematically we can conclude that initially the fluid lying at point B and D, this diagram you can see it very clearly. Initially the liquid is at point B and D. Okay, at small interval of del t, the fluid would have moved, correct? So suppose V1 is equal to speed at B, and V2 is the speed at D. The initial distance moved by the fluid can be taken as. So what is the speed formula? Speed is equal to distance by time. So distance is equal to speed into time, right? Speed into time. So for first case it will be like initial distance moved by the fluid from C to B will be like V1 into del T1, and the distance moved by this one moved by D to E will be so from B to C it is V1 del T1, from D to E it is V2 del T. So pressure P1 at A1, pressure P2 at A2. So first one we have to find the work done. So the work is done by the fluid in moving a point from B to C. So the work done is equal to force into displacement, right? So force into distance. So in this case force is pressure into area. So P1 A1 into distance is V1 del T, and work done by the fluid in moving a distance of D to E, so that P2 A2 V2 into del T. So the net work done will be nothing but we have to subtract it. So W1 minus W2. So by the equation of continuity we already know that volume in is equal to volume out. So AV is equal to constant. So thus P1 A1 V1 del T minus P2 A2 V2 del T, where A1 V1 del T is equal to P1 del V and A2 V2 del T is equal to P2 del V. So therefore work done P1 minus P2 is given by the equation, and also the change in kinetic energy is equal to half m v2 square minus v1 square, and the gravitational potential energy will be mg h2 minus h1. So the total change in kinetic energy will be del E is equal to del K plus del U. On substituting the values and on solving by using work energy theorem, we can just conclude with that derivation that P plus half rho V square plus rho GH is equal to constant. So this is all about the Bernoulli's equation. Okay, thank you.